In this video, we're going to look at the concept of critical angle and how it causes total internal reflection. Okay, we look at how to do basic calculation involving critical angle. Alright, we also look at the relationship between critical angle and refractive index. Okay, so let's look at this question I have here and solve it together. Okay, so the question says, calculate the critical angle for light traveling from glass to air. Alright, we are giving the refractive index n to be 1.5. So we have n to be 1.5. Again, it's important you note that critical angle is the incident angle at which the angle of refraction is 90 degrees when light passes from a denser medium to a less dense medium. Thus, it could be from glass to air. Alright, so in this question, our angle of refraction sine r will be 90 degrees. Alright, because critical angle is the incident angle at which the angle of refraction is 90 degrees. Okay, so we are looking for sine c. Okay, so we have the critical angle. So we are going to apply this formula sine c over sine r equals 1 over n. Alright, we are using 1 over n because the light is traveling from glass to air, that from a denser medium to a less dense medium. Alright, okay, so having done this, let's substitute the values. If you substitute, you're going to have sine c over sine 90 degrees, this is 90, equals 1 over 1.5. so you cross multiply, you're going to have 1.5 sine c equals, so sine 90 will still give us 1. Divide both side by 1.5. Please cancel this, so we are left with sine c equal 1.5. So when you break this thing down, you're going to have sine c equals 1 divided by 1.5. You're going to have, okay, you're going to have 0.66666. Let's leave it at 3 decimal places. Okay, so now to get the value of c, you divide both sides by sine. So this sine can be, so therefore the critical angle will be sine inverse of 0.666, so which will give us, let me punch it. Okay, so I have it to be 41.76 if you are giving it in 2 decimal places degree. Okay, so this will be the critical angle. Alright, now critical angle, when it's exceeded, it causes total internal reflection. Alright, so total internal reflection occurs when the critical angle is exceeded for light traveling from a denser medium to a less dense medium. Okay, so take note of that. Again, note that there are 2 main conditions necessary for total internal reflection to occur. 1, light must travel from denser to less dense medium. 2, the angle of incidence in the denser medium must be greater than the critical angle. Okay, so these are 2 necessary conditions for total internal reflection to occur. Alright, now the relationship between critical angle and refractive index is that critical, let me wipe some parts and show you. Okay, so the relationship is that critical angle, that's sine c, is the inverse of refractive index, or refractive index is the inverse of critical angle. Okay, so this is the relationship. Critical angle is the inverse of refractive index, or refractive index is the inverse of critical angle. So this is basically how you can attempt or solve problems involving critical angle and use it to determine total internal reflection and also identify the relationship between the two of them. That is for this video. Hope you learned something interesting from the video. If you are new to the channel and you have not yet subscribed, sure to hit the subscribe button now to subscribe to the channel. More videos like this, just like, share, and comment on this video. Tell me how you feel for what you learned from this class. If you seem to have any specific questions to ask, feel free to give me a question in the comment section below and I'll be sure to give you a response. That's it for this class. Thanks for watching this video. See you in my subsequent video.